All right, I want to talk a little bit about the tangents and the limits like we were talking about in class today. So first off, if we just were to think about the limit of this function as x approaches 4, the limit exists, the function exists, it's continuous. As it approaches from the left, it's 16. As it approaches from the right, it's 16. The function exists. The function is continuous at 16. The limit exists at 16. All's well. The question, though, is what happens to these tangent lines. So let's say we have this green line. This is tangent to the graph, and I'm approaching this point 416 from the left. As I move here, this guy up here, I want you to pay close attention to. It is giving the value of the slope at every of this line that's tangent to the graph as I move closer and closer. So as you can see, if you just look at the line, you can see that it's getting steeper. And if you look at the slope right here, you can see that this number is getting higher and higher. And when we get to 4, the slope of this line, tangent to the graph at 4, is 8. So that's what's happening on that one. If we instead switch and we look at the another line, the red line. So now we are going to switch which box we look at. Let's just ignore this one for a moment. And let's go to the right side. So this red line, you can see the slope of it starts off pretty steep. This slope is moving pretty high. And as I move towards the 4, the slope gets lower and lower. And as you can see, it also comes to 8. So the limit that we're talking about is the derivative. So we're talking about the limit as this tangent line gets closer and closer and closer to 4. If I were to erase both of these boxes and turn on both lines at the same time, you could see that as these lines get closer and closer together, they eventually turn into the same tangent line and they have the same slope. Now, that's not always the case. Let's consider this spot right here. Now, this has what we call a cusp or corner. Now, once again, this function is continuous. The limit exists. The limit of this function, oh, sorry, I'm writing it incorrectly. Let's make my notation good. The limit as x approaches 4 of this function is -1. So the limit as x approaches from the left is -1. The limit as x approaches from the right is -1. At 4, the answer is -1. This function is continuous at -1. All right, so all the old stuff we're used to still works. All right. Now, again, though, in this situation now, it's the derivative. It's the tangent line that we are focused on. So let's look at the tangent line coming from the right. As you can see, this is the tangent line as we move. And you can see here, this is its slope over here. So right now the slope's about -2. As I head closer and closer to 4, this slope is heading towards -1. And at 4, if I find the tangent line as I approach from this way, the slope of this tangent would be -1. If instead I approach from the left-hand side, this one is actually a little bit less interesting. Let's just block this one out for a moment so we're not distracted. This tangent is always going to be 1. You can still see that red guy, but if you look at the green, no matter where we are on this green line, this tangent line, the slope of the line is 1, the line tangent to it is 1, it's just 1. So as you can see, if you were to take the two sides, let's turn them both on, and you were to bring the two lines closer and closer and closer together, they're not heading towards the same line. Okay, so this red line, as it gets closer and closer and closer, on the right side, we're heading towards a tangent line with a slope of -1. And on the left side, the green line is going to become a tangent line with a slope of 1. So even though this function, the function exists when x equals 4, it's continuous. Oh, sorry, this should say at x equals 4. So fix that if you wrote that down before. It's continuous when x equals 4. The derivative is what does not exist at x equals 4. So these are mutually exclusive, meaning just because it's continuous does not mean that you can take the derivative at that point. So they are two separate kind of limit ideas that are causing the derivative to not exist at this point, because this limit is totally fine What's not fine is the two sides. The two tangent sides are not coming to the same tangent line. So since those don't agree, that's why the function cannot be differentiated at x equals 4. I just wanted to add in this one last notation. So it would be f prime of 4 does not exist. You could still take the derivative of this function for some other points, but f prime of 4 does not exist.